Broadcasting from the commodity capital of the world, Zurich, Switzerland, this is Insider's Guide to Energy.
This edition to Insider's Guide to Energy is brought to you by Fidectis. Go to www.fidectis.com for more information.
Welcome to Insider's Guide to Energy. I'm your host, Chris Sass, and with me, as always, is co-host Johan Oberg. Johan, what's happening?
I'm doing good, thank you. What about you?
I am doing fantastic. We've been going through a number of episodes the last few weeks. It's been a lot of fun. Things that come up on my radar have been about EVs and charging and technology around that. So I'm thinking we're going to go off on that tangent again today. Am I correct?
We are, and I think there's also quite interesting because, we talk about not just the EVs, we're talking about cars becoming, or the electric cars now becoming part of the energy systems. Read two really interesting articles this week alone on hydrogen as well. What are the differences around this? A little bit of a sidetrack maybe today, but it was quite interesting and see the Toyota and the Volkswagen's different views on this. And it's also very interesting to see how that will then tie into the greater ecosystem of energy, especially for homeowners, etc. But there we are. I think it's, as always, more interesting for our viewers to listen to our guest rather than us. So welcome to Insider's Guide to Energy, Manfred Przybilla, CEO of Ambibox.
Hello, guys. So thanks for having me on the podcast.
It's great to have you here, and I hope I didn't slaughter your name too much. As I said from the beginning, it's not
perfect.
My strength with all the names. We always say it on the show as well, because we know a little bit about our guests. Of course, we've been speaking to you before. We have done some research around your company and yourself, but our viewers might not. So maybe give them an introduction to yourself and to Ambibox.
Okay. My name is Manfred Przybilla. I'm the CEO of Ambibox, as you said, and I'm mechanical engineer and electrical engineer. Studied that. And Ambibox is a company which is an engineering, or started as an engineering company in 2015, with the idea of connecting energy grids with three essential parts. Was IoT and Internet of Things, based on Linux systems, then batteries, what we did a lot in the first years, first life and second life batteries, and the other part of Ambibox was always power electronics. This is what we did the first years to earn some money, to get some solid founding, plus technology content into the company in. And since 3 years, Ambibox is going out as a manufacturer, low volume, and we're now on the step to going into high volume manufacturing. And the main products are always bidirectional. That means we are experts for bidirectional power flow. That means power flow in between a battery and an inverter. And what we do right now, which drives us on a daily basis completely, is a vehicle to everything, vehicle to grid, to home, to building, which is also a bidirectional power flow, and it's a battery on wheels. And that's what we're doing. We had the first project out 2017, and we are starting now with a new technology. To this year, so next year, we will have the start of production. Next month, we will have the start of production with wall boxes directly for linking the car to the house and have the bidirectional power flow. That's more or less everything. Ambibox is an engineering company of about 35 people right now, and we're growing rapidly now with the production, not with the engineering side.
So that's an interesting. Maybe you can just give a little bit more light on that, the battery towards the house and how that works, the bidirectional.
So finally, it's a lot of power electronic in between and software in between. For us, the car is the same as a battery. That's why a stationary battery. That's why for us the wall box is only a component in an ecosystem, and the ecosystem is between a battery and an inverter. That means we need to bring energy to the battery or pull the energy out of the battery. Therefore, we need an inverter. We need some software for it. And the difference in between the stationary battery and the car is only the way how we communicate. Yeah? For sure, the battery in the car is much bigger. When we're talking about a stationary battery for a private home, we're talking about 10, 15 kilowatt hours, not more. When we're talking about an EV, then we're talking up to 100, 120 kilowatt hours on battery capacity. And what we are doing is we are linking with our technology the car to the house, to the inverter, and we are able to exchange the energy in between the car and the house in two directions. That means it goes to the house and it goes out of the house. Yeah? So out of the house is the normal charging procedure. Yeah.
Understand that you have a component that goes into people's homes. That seems like a scary proposition to me. You're going into a consumer environment where you don't have control, right? So if you were telling me, hey, I did this for fleets, yeah, you probably have some control what's going on, but every house, apartment building, or wherever you may be going sounds really challenging. So is there a standard or a demarc where this takes place where you can easily plug in, or is there a lot of custom installation per household?
I think that's a challenge because we have several standards we need to fulfill. What we're doing is a nice German word, sector coupling. We are coupling two sectors which are normally not talking to each other, and this is the automotive industry with the cars and the energy industry with all the regulations what we have from TSO, DSO, from the local utilities, etc. And we need to bring them together. And we have on the one hand side definitely the grid side, the energy side. On the other side, we have the car side, which have a clear standard protocol. Those are more or less two standards right now. It's Japan with a CHAdeMO standard, and it's the rest of the world with a so-called ISO 1511820 standard. And we need to bring the standards together, and it needs to work. And around all the standards, we have then other topics like IoT or cybersecurity, which we need to bring together and need to secure that it operates fine and nothing goes wrong, especially when it's in a private house.
So in terms of, we talked a lot about EVs on the show before, and we know the batteries, of course, in terms of the capacity. This is the opportunity I have to ask the stupid questions. But if you look at the market today, how many of the EVs on the roads today are set up for bidirectional?
More than it's official. That's clear because there is the official standard protocol, the two, as I said, the CHAdeMO and the ISO protocol are the enablers. The CHAdeMO protocol is in the market since about 2011, and the Nissan fleet cars, the Mitsubishi fleet cars, since then more or less able to be charged bidirectional or discharged bidirectional. So this is with this standard, everything works fine. The other standard is the ISO standard that was released about 1 year ago. And since then, it's clear, okay, this is the way how we communicate with the car. And so we can start discharging the car also. And then there are some cars in between. For example, the BMW i3 and the Honda E or the some cars from Fiat. You can discharge them, but not with a standardized protocol. Yeah, there's a so-called DIN protocol, and you need to write a protocol of your own to discharge the cars. What we know is from the future that all the car manufacturers are going now for the ISO protocol. That's clear. That helps a lot. The others in Japan are doing the CHAdeMO protocol, and almost every car is capable then to get discharged.
So if we look at the market in general, so that's the car side of it, and then we start looking at maturity also in households, etc. Just as a curiosity, where do we sit in terms of regions and markets of maturity, or maybe this is the test markets that you see where this actually starts to take off?
When we are looking at Europe, especially, then the starting markets are definitely the Nordics, or all the markets with the flexible energy tariffs. I think you talked a lot about in former podcasts about that. Where you have flexible energy tariffs, then we see a high demand because the grid operator or the utility or the end consumer has a business case to operate the car bidirectional. So this is vehicle to home, vehicle to building mainly, and with some smaller fleets for the big picture of vehicle to grid. And these are the Nordics and the Netherlands. When you talk about Europe, then we have the big Japanese market. The Japanese market is already there, and if you would have cars and equipment, you can use it right away.
So the markets are getting ready. You're putting hardware in place. Back to the battery topic that you talked about on the vehicles. I kind of wonder. There's a couple things as I'm learning about batteries. Right, there's a set number of charges you have and discharges, and how do you manage things like that? So are the car manufacturers supporting the two-way infrastructure, and are they engineering that into the life expectancy of the vehicle? Or are you looking at it solely as a storage problem? Are you working with the manufacturers or the OEMs to predict this?
It's more or less both. Yeah. On the one hand side, it's the car manufacturers want to have this topic and wants to have the topic as a USP for selling cars. We have seen the announcement from Volkswagen, and they know they can sell more cars if they're offering vehicle to grid or the bidirectionality. And then we have on the other side the battery itself. So we know everything, or we know that there's big discussions about battery aging and even more battery aging and the loss of the worth of the asset, the battery asset, by discharging them. And as I said before, we have a lot of experience with battery. We started 2015 with batteries and in a really, really, really scientific way. And we know that that's confirmed by car manufacturers also, that this discharge rate, what we do on V2G or vehicle to home, is very small. So if you have the battery of 80 kilowatt hours and you discharge them with 11 or 22 kilowatt, this is almost nothing for the battery. It's more or less a balancing process. So we have no real aging from the discharging cycles. Yeah, it's not countable. For sure, if someone really does it 10 times per day and over years, for sure we will have something, but that's not a business case or the use case. And then we have the calendrical aging. And from one car manufacturer, which is more or less the first one in the market, we know that they see no aging over the last 10 years now from the battery themselves, if they are charged in a really healthy way and discharged.
So one of the early car manufacturers to do two-way or bidirectional was Tesla. I mean, early on, I remember, I think it was a Prius could do bidirectional, and I think Tesla were the first two that I remember in my North American experience. How do they stack up compared to all the new entrants coming in? Is Tesla still leading edge there, or is it just kind of following the standard and falling in with the rest of the pack?
No, you're absolutely right. So, Chris, the Tesla Roadster was the first car being bidirectional. But then they stopped it with the Model S, Y, and Model 3 and Y now. And so there is a jailbreak to discharge the Tesla, but it's not used. And Tesla is not using that. The first car manufacturer which had this feature in was Nissan with the Nissan Leaf in America, and a lot of cars in America still alive have this feature after 10 years. And who's coming up next now is all the rest of the car manufacturers. All are going that way. That's clear. That's what I can tell you because we're talking to everyone in the world.
So when we talk about the OEMs, we've had this discussion before, and especially coming from a commercial angle to this one, you start looking at it from not just from a business angle, but it's also you're changing your setup. Before you bought a car and you fueled it somewhere else and you drove it and it was your car. Now suddenly you have an asset as part of your car if it's bidirectional with your batteries. I would assume that as a consumer, I would assume that I would own this. It will be a benefit to me in my home. But learning from the episodes we've done here and from listening to others, there are many players that want to be part of this one, both the energy companies and also the OEMs. So help me try to explain, how does this work? And obviously you're in the middle of this, enabling it, but surely there's a little bit of a, I wouldn't say a fight, but how does this work?
It's not really a fight. It's a wish. It's a wish and an enlarging of the business case. And starting with the activities of Tesla becoming an utility, having the stationary storage systems and the solar roof tiles and the cars. Many other car manufacturers are saying, okay, let's do the same, using the cars as an energy asset, trying to get some extra revenue out of it, becoming a utility. That's what the announcement of Volkswagen are, for example. And I wouldn't say it's a fight. Yeah, and no, it isn't a fight. It's more or less who is first and who is capable to do that. And as I said, it's sector coupling. On the one hand side, you have the car manufacturers, and I come out of the car manufacturers, out of the General Motors company, and normally a car manufacturer deals with energy when he needs energy to operate their plants. Yeah, this is the linkage to energy for a car manufacturer. And now they are coming to the customer with energy. Then they starting to understand charging. Okay, that's one thing. The cars need to be charged. That's what we see at Tesla with all the chargers worldwide. And now we go to the next step. And there is a big hurdle in between. It's an understanding hurdle. It's sector coupling. Coupling the sector is coupling people together and getting the understanding of an utility or grid operator to a car manufacturer is as hard as vice versa. To give the knowledge of a car manufacturer, of a grid operator, of the car manufacturer, what it's needed, and we are in between. That's what we are orchestrating. That's what we're helping for, and for sure, there are some people are afraid of that Elon Musk and Tesla takes over all the energy grids in the world. That won't happen. Yeah, that won't happen. But I can tell you, Elon Musk will not let any energy provider into his car or his energy asset. So you will see it. It will be a worldwide mixture, and depending on the markets and the structures.
But I guess that's where I'm going with what you're saying and listening is, I see that everybody's salivating at the control of the customer here, right? You have the auto manufacturer saying, hey, if I can do more and bring more value, the relationship changes with the car going future, because now I'm in their power supply. And I'd see the utility saying, well, I can bring more value into your transportation. So there's going to be a little bit of a turf battle going on. Who engages you? So you guys have a charging station. It's going to go into my house. So I've got a single family home. I just bought an EV, and do I get you through the dealership when I buy the car? Is this an option? I go, hey, I buy installation for this box into my house, or do I have to go on the internet, do some Googling, and say, oh, here's a great option. Why don't you guys come out and install it? Or does my electrician recommend you? How do I get you into my house?
All of this our customers, and that's more or less the outcome of my words before. It's not solved yet, and it's differently from market to market. For example, the market entry for our home market in Germany is not clear for us. We know that we can sell B2C some 1,000 chargers, but it's hard to go via a reseller or go via an OEM. In the Nordics, it's completely different. In the Nordics, it's settled. Finland, Sweden, we have our distribution channel, same as in the Netherlands. And there is clear that there we have a reseller, and the reseller sells it to the grid provider, etc., and they have the business cases, or they're running their business cases of their own. Then we have car manufacturers. I'm not allowed to drop the name, but they want to become the next Tesla on the market, or becoming bigger or faster than Tesla. They want for sure sell the car plus the charger plus an energy tariff plus photovoltaic plus a stationary battery plus. Yeah, and that's the complete bandwidth.
So the other element that comes to my mind is code for building. So, for example, my sister redid their house, and when they were doing it, I'd recommended, hey, even though you don't have an electric vehicle yet, you're just redoing your house yet, you're not likely to do it again in the next 10 years. I would put wiring into my garage to handle a charging station. So has code caught up, building code, let's say in Germany or other progressive countries, for new construction to mandate having set up in a garage for charging?
Same here. So we have some general requirements coming from the European Union, coming from the legal states, that they are required in public building or in rental buildings, that there need to be some wires there for connect chargers to it for every parking space, etc. That's there, and that's already done. If they really at the end do it, it's one thing, and the other thing that comes to that is the big problem of having too much power on the grid, or too much. I don't know the word. Yeah, it's to get some grid balancing in. That's they are all afraid that if 10 cars are charged in a parking station or parking house, that the grid goes away. That's one fear we need to handle for sure. And for the private houses, it's more the private case and the motivation of the house owner to have to connect the car directly to the house and do it bidirectional or unidirectional. That's more the motivation from the ownership side.
I can see the motivation, and I think this is something that we discussed in many different angles, also in terms of this changing landscape of the energy ecosystem. Some talks about prosumers, kind of from a consumer to a prosumer, and that means that I, as a house owner, suddenly now, usually I bought a tariff. Okay, this is how much energy I need, and this is what it's going to cost me. Now suddenly, I need to start thinking about, all right, how does this all sit together? Which, in my book, becomes complicated because I don't know what a battery is. I don't know what my car will do. I don't know what tariff is. And suddenly the OEMs are screaming at me and my energy company is screaming at me. So how do you see this? What's going to happen to this ecosystem from your point of view, being kind of in the middle of this?
Again, depending from market to market.
Yeah.
We will have some markets where it's only or just having the car connected to the grid, the so-called V1X, just to control the chargers with the grid, and that's one thing. That's the simplest case, and that should be there everywhere, because it's logical. Then we have the simple case of coming just V2G. This is when I explain it to my mom. It's always the wind turbines in the north of Germany and the big solar parks in the south of Germany, and somewhere in the middle a big car fleet, and you orchestrate the energy in between. This is V2G. But therefore you need to have the operator in between, someone who earns money with it finally, with the flexibility. And what we see, especially in the Netherlands, for example, there we have the case that if you know how to deal with energy in the Netherlands, you can easily do V2G. And then the owner of the car and the owner of the charger only gets some financial benefits. So he gets, I don't know, €100 per month just to charge the car or have the car connected. It's not charging, connected to the grid overnight, for example. So that's the easy business case, or easy to understand, and you don't need to care for it. You just need to open the door that someone installs the charger in your house, and you get the car, perhaps with some leasing tariffs, or you buy the car, and that's it. So the financial benefit is there.
Is there a price point where the EVs need to get to make this work, or does it work if I'm buying a $50,000-$60,000 or Euro car? Does it what? Because some of the EVs are still pretty pricey, right? I mean, I look at where they're at. They're still a premium, and they've come down. Tesla's lowered its rate month over month. I've seen a few different things to try to be more competitive on their pricing coming down. But I mean, when you start getting the battery packs that get you the mileage that a lot of folks would really want, you start adding stuff up, right? I mean, you mentioned the Leaf, but that was, if you're doing local commuting, probably great. If you're looking to go on a long trip, the battery packs in the early Leafs that I looked at, the range wasn't incredible. But where does the economics start making sense for the average homeowner?
Okay. Again, that also depends. Depends on the market, and depends how the market is developing. You come from Sweden. Sweden is now the market where you get the most revenue. Yeah, some people telling me up to €1,000 per month revenue if you allow your car with a 60 kilowatt hour battery to be operated in the grid. So the smart guys would calculate 1 month €1,000, 12 months €12,000, 4 years €48,000. Car is paid. We all know that this kind of business is not working, and if only for a really short time. I see it's an additional benefit, and the big question is to whom goes the €100? Goes it to the owner of the house, or if coming back to the initial questions, goes it back to the car manufacturer, for example, or goes it back to the grid provider? And for the private person, €100 is nice to have. For a grid operator which has 1 million cars or 100,000 cars connected, it's a nice revenue stream.
So what's the motivation then from the owner's point of view? They're doing it to get discounts, right? Typically, or they're doing it to save cash, or why go through the brain damage if the car manufacturer or the grid operator is going to take advantage of the power?
And that comes back to your question: who is going to make it, the energy provider or the car manufacturer? And for sure, for the car manufacturer, it's a big thing, to earn additional money, because normally his revenue is over when the car is sold. And perhaps he gets some money with the own dealership if he sells spare parts. But we all know that the spare parts business in battery electric cars are going really much down. So for him, it's a big, big motivation to earn money with the cars after he sold the car or after he is leasing the car. And we know that most of the cars are still belonging to the car manufacturers. And I think this is what the most car manufacturers really want to go for. Earning money with the car at the customer side, especially when the customer leases the car and the car stays in the ownership of the OEM.
So do you see then as a business model that we not only prices for EVs are going down, we've seen, as Chris mentioned, Tesla doing this was, and I think that's kind of an obvious sign that we will get cheaper EVs, but do you also see then that the leasing models will be more pushed from the OEMs in order to be able to own the energy part of the car as well? Because if you sell it to me, it's my car, then you have a different situation in terms of what you can do and not do. So do you see anything difference in this, or is it still early days?
I know the wishes.
Yeah. Let's go with the wishes.
And the wishes are clear there for a lot of OEMs to become a utility and earn money with it, and keep the car in their ownership and just go for a leasing program like we know it from some mobile phones, etc. So that's clear for them. Operate the assets over years and keep the cars in their asset base or in their ownership. That's clear. That's the big idea of a lot of OEMs now.
Which is interesting, because then you can also, as you mentioned, if you have the leasing of the car, you can also lease the rest of the assets in terms of your power wall, in terms of your solar, etc. So you can build a business case on it. I always come back to changing an industry is not always the easiest way of doing it, but time will tell.
Exactly, and it sounds easy, but it isn't, because again, it's different sectors, and they normally don't speak to each other, and it's so hard to do the conversation in between and the translation in between. And normally, a car manufacturer has nothing to do with the electrician who installed something in the house, or solar people going into the house, and it takes some time to bring that together. But it will come definitely. And today I only see Tesla with the capability to do that. A lot of wishes, like we have seen the wishes from Volkswagen becoming the next Tesla with the former CEO Herbert Diess, who wants to really push into that direction. But I haven't seen an installation from them so far. And we know the announcement from Nissan 10 years ago, and I haven't seen an installation so far.
A logistics question that comes to mind is, so you talked about Linux hardware or hardware software combination, which implies that you have connectivity back to whoever the mother box is, whether it's the utility, whether it's the auto manufacturer, whoever is going to do that, or even the market to do balancing or whatever. Is internet connectivity ubiquitous and expected, or is this something that also, when you go and install one of these boxes, is there a separate connectivity for this? Or are you just dovetailing on what's already in place, mostly ubiquitously for middle class and higher homes?
We have a big and strong background in IoT. That helps a lot. And we are selling our wall boxes from the OEM to more or less to B2C customer. And when we're talking about an energy provider, then we're giving them an API, and he can come down with his cloud software via the API to the charger and operates the charger as he likes to, even in the vehicle to grid case. And then the complete control and orchestration software is on the side of the grid operator. So we don't care. The only thing we care is cybersecurity, connectivity, and load down and upload rates. That's what we do. Yeah. When it comes to more to the homeowner or small business, then we give the customer the capability to operate it off their own. That means the connectivity to the grid is only there if he needs data from the grid, like solar forecast or over-the-air updates for the charger, and then he operates more or less the chargers locally. Yeah. So there is from a single point where we adjust only the over-the-air updates for one single customer up to the complete fleet of a scalable IoT platform, like we see it in the telecommunication. That's again the complete bandwidth again.
When we look at the stakeholders that are part of this ecosystem, I'm coming back to this, I think it's quite interesting. And then we mentioned the OEMs and their leasing wish list, so to speak, if that's, and you can add on a number of things. We came from the telecom industry, we bundled on a number of things and just extended that. So I can understand. Then you have the energy companies, of course. That's a commodity price that they've been selling to this one. And even a lot of the utilities trying to get into installations and all the rest. Not everyone is doing this because it's a different kind of a thing. If we're going towards almost like your own little microgrid, you will have your power wall, you will have your solar, you will have your car batteries, etc. How does the energy companies look at this? The car manufacturers I can understand because they can drive it, but how do you see utility? Is this a big competitor, or is it good for them to have the battery capacity for grid stability? How does this work? So I see it as a big competitor and a fear for them, but I might be wrong.
I think we are just in the middle. They have seen this. The big utilities have seen that as a competitor over the last years.
Yeah.
Right now, they see it as a big chance for new business, and what they see as a competition for the future are the prosumers, the people living in the southern part of Europe, starting in Mainz, where I live, that we can really be energy sufficient or autark over the complete year. And they have to offer us energy, but we don't need it anymore. So they have a lot of effort with us, but we're not buying energy from them. So the competition goes more to the single customer, to the prosumer. And right now, it's okay. So when you talk, for example, to the big grid providers in the 4-1 in Germany, today they are quite fine. They say, okay, every load which isn't on the grid, that means a self-sufficient house, is okay. We don't need to care for it. That's clear. And thousands is good. That's, for example, in Munich we have that case. If you want to install in Munich a photovoltaic system with a battery, the utility, the Stadtwerke are quite happy with that. But we all know if that comes in a high volume and more people becoming energy independent, the utilities are using the business case.
Yeah.
And so the end consumer becomes then the competitor, more or less. That's what we see, and there's a lot of activities in for sure, because a lot of companies, maybe not Ambibox that much, but a lot of companies are really going into that business case and trying to tell the story of an energy independent house.
I think the energy independence house is quite interesting, and I think we touched on the car, which Tesla obviously leading the way for EVs, but maybe not just for EVs, but also in terms of having this vision of the energy independent house with their power walls and solars. We saw recently as well that they're going into heat pumps and etc. Any insight on Tesla around the energy independent house?
I have no insight. Yeah. No more. But I know what Tesla is capable to do, and if you listen to their to the last Power Day or official day they did, Tesla or Elon Musk said clearly that they go into heat pumps and they have the technology in-house. They can scale it, and I'm really sure that they can build heat pumps at a different price level. And for me, it becomes logical now, because we always know, okay, there was a big, when you talk about, especially about Tesla, we talk about Elon Musk, because he is more or less Tesla. And the activities he has at SpaceX and Twitter, sometimes, I would say Twitter was distracting him a little bit from Tesla, but now he goes back. And I don't see Tesla as a car manufacturer. Not at all. I see Tesla as an energy company, and I see that Tesla is going to offer, starting from UK and perhaps, or for sure, California, to sell more and more into the house. That means not only the car, they have their stationary storage systems, they have their solar roof tiles, and now the announcement was adding the heat pump to it. And then it becomes for me logical, because the heat pump is something we need in the house for heating and cooling, and bringing that together with the power wall plus the solar tiles and the car is an energy ecosystem. And he has also the capability, I think it's called energy bidder, or I don't have the right name for it, but they already have this technology, this orchestration software to do so. And we see it in the German market. They do it together with Octopus Energy as a virtual power plant. They have other providers in other countries, and I see Tesla coming into it, becoming big with that. And that's what we have seen at Apple. Yeah, the Apple guys. I'm one. I have an iPhone. I have an iPad. I have a blah blah blah. I have an ecosystem coming from one company, and I think that happens to Tesla also. And a lot of companies like that approach. A customer like that approach.
Yeah, I think I think you're right on that, and we'll see where it ends up. But I think, as I started off a little bit in my conversation, in terms of looking at the consumer, and I am not a technology visionary, but I like the Apple because it was easy to use. I bought one, I bought the second, I bought the third. I have one part, and I think that's where we can go with this one. This has been great. I think we're coming up on time as well. Chris, anything last remarks or last questions from you before we wrap?
I don't really have a question. I mean, I think it's interesting to see where we're at in the journey. As bidirectional charging becomes more and more popular, I mean, VW Group, it's been doing it for a little bit of time now. So if you just look at the scale of number of companies that fall under their platform, it becomes mostly ubiquitous in the car market over time. I do see you're watching Tesla, but I still think it's early innings. I don't see them going away, but I think there's a lot of players that have aspirations to get there. So it's not a foregone conclusion. But I can tell you that when they announced roof tiles, I looked at them right away for my house. And and then would you want to have roof tiles without a battery pack? Probably not. And if you have a car that is bidirectional charging, why wouldn't you take advantage of it? Living in the US when I'm not living in Europe, I'm in a hurricane zone, and it's sure nice to be able to have my car give me some backup. There's a storm, right? So I don't have to rely on the grid for all the power. So I see with the changing climate, at least in a lot of the U.S., where the storms are bad and impactful, and you just look at the recent state of storms to the Midwest, that people are going to want to have. I mean, if you look at gas, diesel, and propane generator sales in the U.S. They've gone up in years. When I was younger, I don't remember people having them. And in my neighborhood in DC, if there's a power outage for the whole area, all you hear is gas generators running throughout the entire day, throughout the entire neighborhood, right? What I'd expect in the near future is I wouldn't hear all those generators. What I would expect is I would see lights on from renewables and having battery storage. So to me, it's an interesting journey. I want to thank you so much for sharing. I look forward to seeing more charging at home and more, seeing the consumers taking control of their energy. It'd be interesting to see how this goes and who wins the battle, whether it's the consumer, the auto manufacturer, the utility, or yet to be named player.
Mm-hmm. Yeah.
Yeah,
thank you.
Pleasure to have you on, Manfred. It's great talking to you, and looking forward to follow this as well, because this is really interesting.
Yeah, thank you, Chris and Johan. Yeah.
Thank you. And for our audience, we hope you've enjoyed this content as much as we have making it. If you don't already subscribe to Insider's Guide to Energy, we encourage you to subscribe. Don't forget we're on YouTube, and follow us on LinkedIn. We'll see you again next time. Bye-bye.